Welcome to the second part of areas related to circles. In this video, we're going to discuss the concept and problems on combination of circles and relation between the distance traveled by a wheel and the number of revolutions it makes. Mainly, there are two ways in which we can arrange circles in combinations. First one is two circles touching each other or intersecting each other. In this video, we'll discuss only the circles which touch internally or externally. When two circles touch externally, the distance between the centers is the addition of the radii, and when the circles touch internally, the difference between the radii will be the distance between the centers. As the distance is always positive, we can take the modulus for the difference of the radii. And the second type is concentric circles. As you can see in the figure, all the circles have the same center, but the radii are different. Let us take a problem on the circles which touch internally. The sum of the areas is given as 116 pi centimeter square, which means that pi r1 square plus pi r2 square equals to 116 pi. Pi can be cancelled out on both sides, then we get r1 square plus r2 square equal to 116. You can take it as a equation number 1. The distance between the centers is given as 6 centimeters, and as the circles are touching internally, the distance between the centers is r1 difference r2 and is equal to 6 centimeters. If we have the equation involving r1 plus r2, then it will be very useful for finding the values of r1 and r2 by simple addition or subtraction. So we can use the identity which is showing on the screen and use two equations we got previously, then we get r1 plus r2 as 14 centimeters. Now by solving r1 minus r2 equal to 6 and r1 plus r2 equal to 14, then we get 10 and 4 centimeters as the radii of the circles. This problem is probably the most important of all the problems we discussed in this video and maybe the previous video also. An archery target board is shown in the figure with 5 concentric circles. The radius of the inner circle and the widths of each of the scoring regions is given as 10.5 centimeters. We are asked to find out the area of each ring, which can be done by subtracting the circle areas, as we will discuss shortly. For this, first we need to find out the radii of the circles. Radius of the second circle is the addition of the radius of the first circle and the width of the first ring. So radius of the second circle is equal to 21 centimeters, which is 2 times the radius of the first circle. Now R3 is the addition of radius of the second circle and width of the second ring, which will finally give you 31.5 centimeters. This is exactly 3 times the radius of first circle R1. So we can express R3 as 3 into R1. Similarly, the radii of the fourth and fifth circles will be 4 and 5 times the radius of the first circle respectively. After getting ready with all of the radii of the circles, it's time to find out the areas of each scoring region. The innermost circle is a goal region, which can be found out using pi r1 square, and by substituting r1 value, we get the area of the goal scoring region as 346.5 centimeter square. Now take A2 as the area of the red region, which can be found out by subtracting the first circle from the area of the second circle. Take R2 as 2R1 as we derived earlier, then we get A2 as 3 pi R1 square, which is exactly 3 times of pi R1 square. We have already found what is the value of pi r1 square, so substitute it, then we get A2 as 1039.56 centimeter square. To find out the blue scoring region, subtract the area of the second circle from the area of the third circle, then we'll get pi r3 square minus pi r2 square. Use 3r1 for r3 and 2r1 for r2, then we'll get A3 as 5 pi r1 square, which is 5 times of the area of the innermost circle. Then we get the area A3 as 1732.5 centimeter square. Similarly, for finding the black region, subtract third circle from fourth circle and we get A4 as 7 times of pi r1 square, which is 2425.5 centimeter square. Finally, the white color scoring region can be found out by subtracting fourth circle from the fifth circle. Then we'll get the area of the fifth scoring region also. Thus, we found out the areas of all the 5 scoring regions. In this third problem, the ratio of the diameters of three concentric circles is given as 1:2:3, and we are asked to find out the ratio of the areas of the three regions so formed. As the diameter is 2 times the radius, and by the properties of ratios, the ratio of the radii will also be 1:2:3. We can assume these radii as x, 2x and 3x units respectively, as they are in the ratio 1:2:3. The area of the first region A1 is nothing but the area of the innermost circle. By calculation, we will get it as pi x squared square units. The area of the second region is obtained by subtracting the area of the first circle from the area of the second circle. Thus, A2 will be equal to 3 pi x squared square units. In the same way, the area of the third region can also be obtained as 5 pi x squared square units. Now, the ratio of these areas will be 1:3:5 after cancelling out the common term pi x squared. And this is the fourth problem in this model. You can see a blue circle in the diagram, which is a circular pond, and the region between these two circles is the path surrounding the pond. The diameter of the pond is given as 17.5 meters, and hence the radius will be 35.4 meters. Width of the path is given as 2 meters. Let us assume this as W. The radius of the yellow circle will be the sum of the blue circle radius and the width of the path. To find the cost of constructing the path, first we need to find out the area of it. Subtract the blue circle area from the area of the yellow circle, then we'll get the area of the path. For simpler calculation, I am using the identity a square minus b squared equals to a plus b into a minus b. To find the cost of construction, multiply the area of the path with the cost per unit area. When a wheel completes one complete revolution, it covers a distance equal to its own circumference. Hence, the distance travelled in one revolution is 2 pi r units, where r is the radius of the wheel. If the wheel makes n number of revolutions, the distance will be n times the circumference of it. Basing on this concept, let us do a couple of problems. In the first problem, already the distance is given and we are asked to find out the number of revolutions made by the wheel. As we know, distance covered is equal to n into 2 pi r. Substitute the distance and radius values, we get the number of revolutions to complete the distance of 792 meters. In the second problem, we need to find out the speed. In this problem, number of revolutions per minute is already given as 140, which means we can find out the distance travelled by the cycle in 1 minute using 140 for number of revolutions. As we know, speed is the ratio of the distance to time. 264 meters is the distance travelled per minute. Multiply it by 60, then we get the distance travelled in 1 hour, which gives the speed of the cycle as 15.84 km per hour. In the next video, we'll discuss the concept and problems on area, arc length and perimeter of the sector of a circle. See you again in the next video.